Hi chemistry peeps, Color here. I'm going over molarity practice for 3.2 solutions. Okay, you'll find this in order in the module for solutions. You'll see molarity, then dilutions, and then calculations. So let's talk about molarity first. I'm just going to do a few. I know there's 17, but you can do them just fine. I'm just going to show you how to do a few of them, and then you'll be fine. And if you have any questions, of course, please let me know, okay? And when you turn it in, I'll send you the answer key, okay? All right, so remember the big thing here is molarity equals moles of solute over liters of solution. And that is super important to remember for all of this for solutions, okay? Now, numbers 1 and 2, I've just written the same way. They're written the same. They're done the same exact way. So I'm only going to do the first one, okay, since they're done the same way. So using this right here, okay, it says calculate the molarity of a sugar solution if 4 liters of the solution contains 8 moles of sugar, okay? So all you have to do, since you've been given 2 liters, this time we will have to convert from milliliters to liters. And I'll show you how to do that. It's super easy. But this one was given to us in liters. Okay, so moles of solute. So we have 8 moles of sugar. Okay, 8 moles of sugar. Okay, over liters of solution, and we have 4 liters as it told us in the question. So what is 8 divided by 4? That is the molarity, which is basically the concentration of the solution. Okay, so 2 molar solution now is what the sugar solution is. Okay, technically you can do this if you are making some Tang or some Kool-Aid or some like powdered sweet tea even. You could calculate this if you were able to get how many moles of the sugar, and I'll show you how to do that, and you can calculate your own molarity or concentration of your solutions that you're going to drink with the Tang or the Kool-Aid or whatever. So you can definitely send those to me for extra credit. I would love to see your videos or explanations of those, okay? Number 2 works the same way as number 1, okay, so I'm going to move on. Number 3, what is the molarity of a solution containing 5 moles of solute and 350 milliliters of solution? Well, 350 milliliters has to be converted to liters. So I already did that over here. It says convert 350 milliliters to liters. All you have to do is a liter is 1,000 milliliters. So you take your milliliters and divide it by 1,000 milliliters, and your decimal is what you get. That's in liters, okay? So 350 milliliters is 0.35 liters, okay? So now we can go on and calculate the molarity, okay? And so all we have to do is take, again, our moles of solute, which it told us was 5. So 5 moles of solute. And now what is our solution? Our solution is 0.35 liters. So now I'm going to take my handy dandy calculator, okay, and I'm going to take 5 divided by 0.35, and that gives me 14.23. Okay, and that is the molarity of our solution now. Okay, which is quite a high molarity. We normally don't deal with solutions with that much molarity in the lab. All right, moving on. Number 4, I've given a big explanation here, so I want to go over it. How many moles of Na, sodium, are needed to make 4.5 liters of a 1.5 molar Na solution? So here's the explanation. A solution of molarity of 1.5 requires 1.5 moles of sodium to every liter of solvent, okay? Hence the molarity equation up here. 1.5 moles of Na into 1 liter renders 1 liter of 1.5 molar solution. So multiply molarity of the solution by the end volume. Okay, so the end volume is what? 4.5. So if we take, and that's going to require 6.75 moles. So if we take that 1.5 and just multiply it by the 4.5, that's our answer, 6.75 moles. Okay, so we just had to work a little bit backwards on that one. So let me know if you have any questions on that one. All right, number 5, I want to talk about that one. So how many moles of NaOH are needed to dissolve in water to make 4 liters of a 2 molar solution? So a solution with the molarity of 2 requires 2 m of NaOH per liter, hence what I've been harping on, this right here. Okay, so what does that mean for us? Okay, and in this case, that means all we have to do is take the 4 liters and multiply it by the 2.0 molarity, which of course is going to give us 8. And that's going to be an 8 molar. Okay. Let's see. The next one, let's do number 6. So how many grams of potassium carbonate are needed to make 200 milliliters of a 2.5 molar solution? Well, the first thing I needed to do was convert 200 milliliters to liters. And I did that over here. So 200 milliliters over 1,000 equals 0.2 liters. Okay. And some of y'all can do that just by moving the decimal point. I like to show how it's actually done so that we have a full understanding. So now what do we do? Okay, remembering what molarity equals, okay, we may have to move things around for this one like we did for the other one. So if you take the concentration and multiply it by the volume of the solution, okay, so that means we are going to take 2.5, that's our molarity, which is our concentration, and we are going to multiply it by our volume, which is 0.2 liters, and if I did my math correctly, should be 0.500 moles. Okay, and I should have said moles here instead of molar. I apologize. Okay, so I hope that makes sense. Okay, please, please, please ask me questions, okay? Now, number 7 works the same way, okay? So what I drew a line right here, and I want you to do that on your paper because these are worked a little bit differently, okay? So guess what you should be looking at? Your map. This map's never going away, I promise. Okay, so how many grams of ammonium sulfate are needed to make a 0.25 molar solution at a concentration of 6 molar? Okay, so how am I going to figure that out? So you always start with what you are given. And what are you given in this? You're given 0.25. Okay, so that's what I'm going to start with always. Okay, all right, now... All right, I'm going to put, since it said a concentration of 6 molar, that's the next thing I put, and that goes over our generic 1 liter, okay? And then over that, why am I putting 114? Okay, because that is the amount of ammonium sulfate molar mass, okay? So now if you calculate that, you've got 171.2 grams are needed, okay? So that was the molar mass. All right, let's look at number 9. How many liters of a 4 molar solution can be made using 100 grams of lithium bromide? Well, over here I wrote out my lithium bromide, and then I looked it up on my handy dandy reference tables, and lithium is 7 atomic mass, and bromide or bromine is 80, so that equals 87. Okay, so the first thing you're going to do is start with what you know always. Okay, and what did it give you? It gave us 100 grams, so we're going to start with 100 grams. Okay, and now their map's going to tell us that we're going to say 1 mole of lithium bromide, and we're going to put that over our molar mass of that we calculated of lithium bromide. This should look familiar to you. Okay, and now we're going to use 1 liter over how many moles, and we're looking at a 4 molar, so 4m. And all that, if I did my calculations correct, should be 0.29 liters, because that's what it was asking, was how many liters. And you can cancel everything out here except liters. Okay? Do you see moles here, grams, and we're left with liters. Okay? So I hope that makes sense. And again, all you have to do is let me know if you have questions. Now, the rest of these pretty much work the same as these two from 8 through 17. So just let me know if you have any questions.